Hi there, I'm Rob Gatroy, Principal Consultant with Armoured Consulting, and welcome back to our series of industry conversations. In our role as independent consultants to the civilian armoured vehicle industry, one of our primary goals is to provide up-to-date information that is of a high technical content for members of the industry, particularly for procurement agencies, fleet managers and users. Today we continue our series of industry conversations by bringing you a conversation I recently had with Chris Hannant. Chris is the Managing Director of Tyneside Safety Glass, a UK-based company specialising in the design and production of transparent armour, also known as ballistic protected glass or safety glass, that is used in civilian armoured vehicles. In this conversation, we spoke about the challenges of manufacturing and the through-life support of transparent armour for civilian armoured vehicles, the importance of customer collaboration, and also end-user understanding as to how best to maintain the glass in the field. We also spoke about the intricacies of maintaining a quality assurance program in the design and the manufacturing process. We covered topics including the need to balance protection and manufacturing costs, as well as the significance of ballistic testing standards within the civilian armoured vehicle industry. Chris also spoke about the challenges that the current ballistic testing standards face. I hope you enjoy this wide-ranging conversation as much as I had in recording it. And please don't forget to hit the subscribe button below in order to keep up to date with all the videos that we release on our YouTube channel. So it's enough for me for now. Please welcome Chris Hannant. All right, so welcome to Chris Hannant, who is the Managing Director of Tyneside Safety Glass, a UK-based manufacturer of what we would call transparent armour, ballistic glass. Chris, welcome to the CAV Forum Industry Conversations.
Thank you. Thanks for the invitation. It's appreciated.
Excellent. Well done. So you're actually the first of our conversation people with our new office. So I've been able to display my Australian footballs, and
I'm privileged. Then I'm very privileged.
Indeed, and in fact, and not just for you, but I have my little waving hand of the Queen, who I am.
I can see that actually. Yes.
Indeed, but I don't get too much sun.
I need one for my office as well. Then.
Indeed, no, I'm one of the last royalists of the Australians, I have to say. Very good. All right, so let's get started. I've known Tyneside for a number of years. I met you at probably a DSCI exhibition a number of years ago, I think it was, or a Satori. So why don't you tell us a little bit about your background, how it is that you've come into being with Tyneside, because you do have quite a history with the company, and also a little bit about the company background and its history.
Yeah. So we're a very proud third-generation privately owned business based up in the northeastern in England. We've actually been established since 1937, still owned by the same family to this day. We actually started glass processing during the war years, where we used to make glass for gas masks and Spitfire windscreens, which we actually still make Spitfire windscreens to this day for various museums and private collectors throughout the world. So that's quite interesting. Over a period of time, we evolved into the ornamental glass products, and then very much more into the automotive and specialist glass products, which we're in still to this day. Although we're a privately owned business, unfortunately, it's not my family who own the business. However, I have a very long history with the business because I'm second generation. My father was the previous managing director before me. So I've had an interest in the business for over 40 years. And I've been working actively in the business for 27 years, and I've been the managing director for 22.
Look, all the honour. That's an amazing history a company to be around, owned by the same people for getting on 100 years soon, and for a generation in
no, it's quite unbelievable. It's a lot of people sort of say, "Oh, we've had a business that's well established for 25 years," and when I tell them ours was being established since 1937, it's a huge surprise, because there's not that many businesses have survived that long, especially privately owned and by the same family. So it's quite an interesting history.
Indeed. And I believe that you've actually moved to new premises. I think you've expanded your operations and modernised over recent months.
Yeah, that's correct. So we did it. We opened a new manufacturing facility last September. And that was, it's a new 50,000 square foot manufacturing facility that is specifically for the manufacture of transparent armour, bullet resistant glazing, specialist multi-composite glass products for rail, windshield applications, etc. So yeah, it's a fantastic new facility, state-of-the-art equipment. We invested a lot of money in it, and it's a really, really good manufacturing facility that we're exceptionally proud of.
All right. Can you, maybe this is a good time, some of the products you're talking about, fire, glass for a Spitfire. I imagine you don't manufacture too many of those a year, do you?
No, as I said, 2 or 3 times a year we'll get an order for something like that, but it's definitely not the mainstay of our business these days. As you can appreciate, there's not a huge amount of Spitfires around these days. So the business is very much focused towards the transparent armour for civilian armoured vehicles, military vehicles, cash in transit, as well as complex flat and curved windshields for use in locomotives and trains. So very much focused on that highly engineered specialist multi-laminate composite products. We also have a separate part of our business that specialises in the manufacture of large windshields for the bus and coach industry. So the very large buses you'll see, particularly around the UK, if anyone's visited London, the new bus for London, etc., we're capable of processing windshields 3 meters in length by 2 meters in height with a 500 mil depth of bend. So huge windshields. And we also manufacture to the specialist motorsport industry, lightweight heated windshields, and also for construction and agricultural vehicles. All of those products, though, have always been manufactured and are currently in the UK, precision engineered in the UK, and we export our products all over the world.
Amazing stuff. And look, certainly we'll probably talk about a bit later about the manufacturing challenges that such a broad range has. So the core product obviously is glass, but there's glass, and there's glass, and they're not quite the same, red apples and red.
No, significantly different processes between them all. And Indeed. Each one has their own challenges.
Absolutely, I'm sure. And we'll hopefully we'll talk about that a little bit later on. And so you export around the world. So that's a very positive thing. And so your clientele would seem to be public authorities, public transport, military, police, I imagine, as well as diplomatic missions, NGOs, people like that. Would that be right?
Yeah, as well as we don't always necessarily be involved with the end user. Sometimes we are, but the majority of time for armouring, for example, it would be mainly to up-armouring companies. So we deal direct with the up-armouring companies who then sell the vehicles on to the end users.
Okay.
We do deal direct with certain military companies as well as certain police authorities as well. But a lot of our business is to up-armouring companies.
Yeah, as a component supplier. Well, that makes sense. Indeed.
Yeah.
I think what would be interesting for people to hear is if you can give us a brief history on the production of safety glass, and how it's actually made. And people look at a glass, like the glass behind me, and it's a single sheet of glass. And that's one process, but then to make safety glass, transparent armour, is taking the same and it's much more complex. Can you give us a brief rundown about the process to manufacture transparent armour, and also maybe some of the history, how it sort of came together that people worked out how to actually make this.
Yeah, without giving too many trade secrets away, just a very, we could be on for a long period of time. But just a brief overview is transparent armour or bullet-resistant glass, whichever you want to call the product, is processed by laminating multi-layers of glass into layers and polycarbonate. We then process those products in either a flat or curved form, and then laminate all of those products together to ensure it meets the ballistic threat level at the right quality expectations for our customers. So that is a very basic overview. It's obviously a very complex process to go through, and because of the quality of the products that have to be manufactured, it's a very labour-intensive process as well.
I understand. All right. You talked about the curving of glass.
Yeah.
And people who are involved in the industry, any industry that involves transparent armour, whether military or civilian, once you start to curve glass, there is this risk of visual distortion due to the curvature. Maybe you're able to explain about how you actually, for what you can say, how you actually curve the glass in order to minimise that risk of the visual distortion due to the curvature.
Yeah, very much more. It's to do with the tooling that we use. So tooling is exceptionally important to have the right quality tooling, but how you heat and how you heat the product up, you have to heat the product up very slowly and then cool it down very slowly. Any radical changes in temperature, the glass cracks and breaks. So an average cycle time to bend the multi-glass layers is anything 10 to 12 hours per bend cycle. So it's a case of gradually heating up and gradually cooling down. When you bend the glass, it doesn't have any of the interlayers or polycarbonate incorporated. It's just a glass construction itself at that point. And then when you go to laminate the product, each layer of glass is individually separated, cleaned, and then laminated together in a very staged process to ensure we have that right quality product. But it's very much about the tooling and the bending cycle that you use to ensure you achieve the right optical quality that we need. Obviously, it's where we're processing potentially very thick glass, where optical quality is utmost important for the people who are driving those vehicles. So it's a key characteristic, and it's the inspection criteria that we have to go through at every stage is absolutely critical to ensure that we are achieving those standards.
Indeed. And I recall one of my early projects building civilian armoured vehicles, and I was speaking with the uparmourer at the time, and we were talking about the curvature, and one of the challenges for a windscreen is that it's a multi-dimensional bend. So in the front, it's actually bending, if you like, horizontally, and it's also bending vertically.
Correct.
And that tremendous challenges. And I've had
and obviously now on vehicles, the design of vehicles, especially on windshields, on occasions becoming very complex curvatures, double curvature bends. We also have other scenarios which are being involved, lane assist, etc., cameras to accommodate. So there's lots of new issues that are coming that we're having to work around with the up-armouring companies and end users to try and evolve our products to make sure that they achieve the end goals that they need in the vehicles.
Absolutely. And in fact, I was visiting an up-armourer just as a hello catch-up visit, if you like. And I'm looking through the windscreen, and I have to say it was exceptionally disappointing, to the point that we took the vehicle for a test drive, and think I was sitting in the front, and I have to say I started to feel ill.
Yes.
Because, and that's a very common side effect of that visual distortion.
Yeah. And that is also sometimes as well as the complex curvature that some of the windscreens are. It's the rake angle that they're actually that the manufacturers are designing as well, which has an effect. Ultimately, though, that windshield should not have got out of to that end user in that condition, because it should have been thoroughly inspected for optical distortion before it was actually dispatched. So if ever we do have an issue, I'd like to think we're perfect all of the time, but as you can appreciate, as a manufacturer of specialist glass products, we do have issues on occasions. And each individual windshield and each individual glass that we manufacture is individually inspected, and every windshield is inspected rigorously to ensure that it doesn't have any optical distortion in there.
No, indeed. And I think that's, one of the aims of this series of conversations and the CAV Forum itself and the work that we do as a consulting firm is speaking to the clients to say that it is actually possible to build a very good vehicle, a very high quality vehicle through the manufacturing process, through the various components that are used. And yes, you can shave, $1 here and $1 there by going for a lower quality component. The problem is that you add subpar quality components into the vehicle with another one, and then extrapolates to the point that the vehicle really, you might have saved $10,000, but this is just not a vehicle that people are going to be happy to drive in, whether it's a comfort aspect, a safety aspect. I've been in the wake of the wrath of an ambassador or a head of mission who said, I don't know what you people are doing and I don't know who manufactured this vehicle, but it's just not on. And so people were hoping to prove it along the way.
It has to be taken into consideration, but at the same time, that can't be to the detriment of the quality of the product.
100%.
And I do feel that on especially the transparent armour products, people are very conscious of that. That you may be able to get a cheaper product, but what are the problems associated with that?
Indeed.
And that's what we pride ourselves on, to ensure that we supply the best quality product that we can and ensure we've got the robust internal procedures in place within our business to ensure that when the product is dispatched, it's right to the end customers. And if we do incur any issues, then they're identified on our premises before it gets to the customers.
Indeed. And it comes back again. There's a relationship between the end user, you as the component manufacturer, and the up-armouring company. It's a tripartite relationship.
Exactly.
But that it is a relationship. It's not a customer and a supplier. That's fine when you're buying a ballpoint pen. That's terrific, because a pen is a pen, give or take, obviously. But when it comes to a protected mobility, people going into harm's way, and the engineering, the systems engineering involved, that brings it together to ensure that there's the optimal quality of the componentry, the assembly, the engineering of the system itself, and the end user understanding it, appreciating it, and how to use it. And that's really what should be driving the industry.
And I think that that is taken into consideration quite regularly, and that's why we have some very long-standing relationships with customers, because they know the type of company that we are. We know how much they value the quality of the products that we manufacture, the levels of communication and service. It all needs to be taken into consideration, particularly on a product that is ultimately purchased to save lives.
Indeed. Following on from that then, given the relationship you have with the up-armourers, who have a relationship with the users, who have, if you like, a relationship with their mission scenarios and their operating theatres, how Can you give us some ideas of how you see transparent armour developing over, say, the next 5 to 10 years? Maybe different designs, different materials. The number one issue of everybody is always weight, and between the opaque armour and the transparent armour, there's another 1,000, 1,500, sometimes more kilos going into a vehicle. So you have to shed any light on how you see the product developing over the coming years.
Well, possibly I can comment on how I've seen it evolved over recent years and how it seems to be evolving. And first of all, there's a lot more companies involved. There's a lot more uparmourers. So there's also seems to be better design and knowledge within the industry now, better than I've seen for a long period of time. You've already touched on it very briefly, but there's a drive for improved protection, to reduce weight, and also then be conscious of the price. But when you're taking in improved protection and reduced weight, at that point you are then incorporating, on a lot of occasions, far more bespoke and specialist materials which are higher priced. So it's a balance between all of those as to how far you can actually reduce the weight and constructions, but still to resist the perceived threat that you've been told needs to be achieved. And it's a real balance between all of those and the cost as well. Obviously, the other thing that I've seen that changes, it's changed quite considerably as well over the recent years, is the introduction of new testing standards, which incorporate whole vehicle blast and ballistic testing rather than individual material coupon testing. And that's definitely changed the industry and the way I've experienced over the last few years.
Indeed. Look, it's exactly what you're saying, and it's interesting that the ballistic testing for vehicles particularly through VPAM, the BRV, which is an open standard, has been a dramatic improvement as to what it was. I remember 20 years ago dealing with armoured vehicles, building for the Australian Defence Force going into Solomon Islands. And it really was, a little bit of they'll be right, we'll make it work.
I've seen that in the past as well. Yeah, it was very, very basic many years ago, and it definitely doesn't seem to be like that anymore. Of the customers who we deal with, anyway, it's evolved, and the market seems to be constantly evolving and changing, and obviously we as a key supplier to these companies need to continue to evolve with it and try and accommodate those changes and evolve our business accordingly.
Indeed. Certainly in the past, it was, if you'll pardon the pun, it was hit and miss into understanding the level of protection. And so the standards that you're talking about are giving a level of comfort to both yourself when you test the product that, yes, your manufacturing, your design, your raw materials used to create the end product is meeting the required level of protection, and comfort for the end user, knowing that when they buy a piece of glass from yourself or the other manufacturers, if it has been tested, then it is such that it will give them the level of protection when they go into harm's way. So one of the questions that always comes up is, with a piece of glass, you can test a piece of glass, a windscreen, whether within the vehicle or separate, and you'll do it to the BRV standard, and that's great, and they'll do the 3 shots and everything's great, and they'll say, yep, terrific, you passed. The next piece of glass that comes off the line, you can't test it because you're going to destroy the glass. So can you describe for us how it is that you then balance between periodic and sample testing of your production to then verify the level of protection through quality assurance processes, through lessons learned processes, so that when you send out a piece of glass, you can then say, yes, it'll be at a B6, B7 standard, etc. Therefore,
Yes.
viable for a VR7 certified armoured vehicle.
Yeah, so firstly, our customers will normally come to us with a perceived threat. For example, you've just mentioned VR7 there. So they'll come to us with a perceived threat. Now, for example, VR7, because it is quite a commonly used standard, we have a construction already tested and certified to meet that ballistic threat level. However, if we roll back when the VR7 first came out, we had a look at what that perceived threat level was. We then looked at a construction that we feel would meet that perceived threat. We actually have our own test facilities, ballistic test facilities in-house. So we carry out our own testing in-house first to ensure that we are confident that we'll meet that standard. And then all of our constructions get externally tested and verified by an independent test facility, either in the UK, in Germany, or in Australia. So each one of our products is individually certified and independently tested. And we then have that certification that then we can prove that our product meets that ballistic threat level. We then periodically carry out tests internally to ensure that our product is continuing to meet that standard.
All right. And that's great. It's to some extent it's easier with a batch of opaque armour because you can cut a square metre and you can test every sheet, every batch. You can't do it with glass.
No, as you've said, you can't test a piece of glass, which is actually then going to be fitted in a vehicle, because with glass being the nature of glass, it's going to be unusable. So it's due to, we have to have robust manufacturing processes in place to ensure that that gives us the consistency of product, and then also regular testing to ensure that our products are still meeting the perceived threat levels that we are supplying the product to achieve.
Indeed. And no, look, I think that's the way, and having that in-house testing so that according to your own quality assurance processes and operating procedures, X number of glass coming off the line, so to speak, is then tested. And so then you can pick up, and that's certainly part of the sort of a lessons learned process, where if you pick up a manufacturing or a design error, you can actually then feed that lesson back into the production process.
Yeah, and it works. If we ever get a glass which is reject, maybe it's for an inclusion or something like that, because we have very strict inspection criteria, which we'll then subsequently have to reject, we will test that product as well again. So we have our regular and robust testing criteria, but also if we do have a reject, which unfortunately on occasions we do, that will also be tested, which is actually a fully finished curved product as well. So it's actually what would be fitted in the vehicle. So it's something else that we do regularly. Right. Not that regularly, because that means we've ended up having too many rejects, but these things do happen.
And look, I think that's, again, part of a quality assurance process and lessons learned to balance, to know when to have internal testings to ensure the quality standard and production standards reached. Obviously, each glass you manufacture and you shoot up internally yourself is a cost. Now, it's a cost of doing business, and there's a weighing up and a balancing of all those aspects. One of the other issues that commonly comes up, obviously by the end users, is that of delamination. So maybe you can spend a few minutes and describe for us why it is that delamination occurs. Does the delamination affect the ballistic protection integrity of the glass? And then thirdly, what it is that users can do to reduce the risk of delamination, which therefore extends the life of the glass and therefore reduces their through-life operational costs.
First question that you raised, how do you try and avoid it? Initially, from our perspective, we manufacture the product correctly. So we use the right manufacturing techniques with the right personnel involved in the processes. We test the product accordingly to make sure that it meets the ballistic criteria and that that's acceptable. And with our industry knowledge and experience, we've built up a robust manufacturing process, which should hopefully ensure that our products do not delaminate.
And over a period of time, the glass will eventually delaminate. It's going to happen.
Yeah.
The question, the time frame, but can you explain the science or the reasoning why glass does delaminate and you get that fogging effect around the glass?
First of all, it can be down to poor manufacturing techniques. So that it can occur because of that. I've experienced issues where I've seen glass delaminate on vehicles which are almost brand new. Not ours, thankfully, but I have experienced and seen that before. I've also had a situation where we have to ensure that the up-armouring companies fit the glass correctly with the right techniques and the right material, because that can also cause significant issues on and contribute towards delamination. Then the end users themselves have a requirement that they need to look after the product correctly. So we have a protocol and criteria that goes out with each individual glass that we dispatch to give them guidelines on how to look after the product. Also make sure that the vehicles are not parked in direct sunlight, etc. So it's an amalgamation between the glass manufacturer as ourselves, the up-armouring companies to make sure that they're taking their responsibility and doing their job correctly, but also right to the end user to make sure that they're looking after the product correctly. How many times that we've seen before where we've had questions of why a customer is having problems with their glass, and they're using glass cleaner on the internal face of polycarbonate. And these are the type of things that it's trying to educate the end users as best we can and as best the up-armourers can to ensure that everyone has a joint responsibility to ensure you get as much longevity out of the product as physically possible.
Indeed. And actually, you raised a really important point that we harp on to our clients and in the CAV Forum incessantly, is that it is a multi-layered approach, a systematic approach. And it starts, if you like, again, from the component supplier, the up-armourer, the procurement office of the organisation buying the vehicle, the regional office is usually in charge of distributing and maintaining in a particular country or a region, down to then the drivers and the fleet manager in the field. And one of the challenges in the industry is that the driver who might be sitting in Garaway in Somalia doesn't quite have the information that he really does need, doesn't have the education, the training, so that he does look after the glass in the correct manner so as to ensure that the longevity of the glass is as per expectation. Yeah. If he doesn't have that training, he doesn't have the culture of how to clean the glass, how to maintain the glass. We see a number of times those suction cups for the mobile phones stuck on the inside, or double-sided tape onto the inside of a glass. And
satellite navigation systems, we've seen it all. And then you get a photograph to say, can you explain why this may have occurred? And there you go. There's a satellite navigation stuck on. There's you name it. I'm sure anyone in the transparent armour industry has experienced very similar discussions with their customers. And it's about education throughout the whole process, right from the company who manufactures the transparent armour right to those end users. Now, whether or not it's always getting to those end users is questionable.
I keep coming back and for a reason of the issue of the lessons learned, that when the user then says we've got a delamination. He reports up the chain through the country office, the regional office, the procurement office, back to the uparmourer, back to yourself. That say, well, this has been causing, you can see, for example, the outline of the suction cup or the double-sided tape for the sat-nav cradle, etc.
Yeah.
That it's fed back not only into training, but into the culture, into the standard operating procedures, so that it doesn't happen again. Fortunately, what we've seen in the field is it happens regularly because the driver say, well, I didn't know. Well, we've told you. What do we need to do to change processes to ensure that this won't happen again? Buying a new windscreen, getting it shipped to a remote area and getting it fitted is thousands upon thousands of dollars. And in today's environment of budget constraints is actually more and more important. And an interesting example of that, I did a visit in Afghanistan a number of years ago when I was with the Australian government. And I was travelling in the vehicles, obviously, and I noticed all these scratch marks on the lower part of the inside of the windscreen. And I couldn't work it out. And I made the comment to the drivers and to the commanders. I said, why is the inside scratched? And the answer is, oh, I don't know. Oh, yeah, okay, rightio. So we hop in the vehicle and we go out on mission, and the commander has a clipboard. And he's got all these notes of what is going to happen for the mission.
I think I know exactly what you're going to say.
And then he basically goes to the top of the dashboard and it rubs against the inside of the windscreen. And I made the comment,
which isn't, and to this, at the same point, a lot of end users don't even know that the internal face is actually predominantly a polycarbonate rather than a glass, which is why it has to be treated totally differently. So, and all of the polycarbonate by nature is even when you do have a hard coat on, which it does, is a product you've got to be very careful with. So, all of those things that we've discussed has an impact on the long-term durability of glass, of bullet-resistant transparent armour.
All right. Okay, so the current trend and the flavour of the month, that's the word I was looking for. The flavour of the month obviously is AI. And maybe it is that you can share any thoughts that you may have in relation to what role you think AI might have in your design capability, your manufacturing, the way that, and even future technologies in relation to how you think transparent armour might be made in the foreseeable future.
Yeah, I definitely think there'll be a future use for it, but as we're very aware, it's evolving very quickly at the moment. So we're having to review and see where that may help us in the future. There are various areas that we're looking at the moment, and again, as it evolves, we'll have to adapt to that moving forward. I know our quality team are looking at automatic defect detection, potentially more accurate quantification of potential distortions in finished product, predictive modelling, search models for finding new materials that we could use, as well as simulated testing on new materials and ballistic constructions. So there's a huge amount of areas that we're looking at the moment, and I'm sure there's going to be significantly more moving forward as the technology evolves. I also feel that there's a potential of how we actually operate our manufacturing facilities and plan them accordingly as well. So I do feel that there's an opportunity there. So there's huge amount of areas that we're looking at, but we'll have to decide what's going to be right for us and give us any real benefits moving forward.
One of the other challenges facing manufacturers like yourself is obviously the geopolitical sphere. I'm an avid reader of the Times. London newspaper and the various challenges in the UK market. We have Trump version 2 upon us, and that's having literally global effect in many aspects, and certainly on the funding side for a number of the NGOs. Do you have any thoughts as to, from your own business side of things, these geopolitical economic challenges going forward and how that will impact upon your business?
As it stands at the moment, not a particularly great situation for the world that we live in, but there's a definite need for increasing demand for bullet-resistant glazing, armoured vehicles, and protection equipment. Good for our business, especially that we've just invested in the new manufacturing facility, but it's really a sad indictment of the world that we live in at this point. But there's a definite demand. We're seeing an increased demand over recent years, which hopefully for our business, it will continue.
Indeed. Look, it's what you've said, the evolving nature of the industry is certainly there. And again, if we go back, you've been in, I think, 27 years you've been working in Tyneside, 22 years at the top and driving, pardon the pun, driving the business. And my first experience was, again, dealing with armoured vehicles that the ADF, Australian Defence Force, was using in the Solomon Islands going back to probably 2002, when there was the police action that Australia was involved to bring stability to basically a civil war there. And the technology involved in the vehicles at that stage, which is only 23 odd years ago, was, with all respect, infantile. And the products have matured significantly over that period of time. And there are these ongoing challenges. We talked about weight before. And it's a bit like software code. The early software produced by the Microsoft had a certain number of lines and performed the task. Now there's literally billions of lines, hundreds of millions of lines producing very wonderful tasks. We're talking about AI. And so it's easy for people to, I think the challenge, let me rephrase that. I think the challenge for the industry is to build a better product that is better priced because of the nature of the vehicles that we're dealing with, in a more efficient way, producing a vehicle that is lighter, that is lower cost to produce, lower cost to maintain, and so then allows more product to go out to organisations that are going into harm's way. Harm's way is not changing anytime soon. And so our ability as an industry to be able to facilitate better product, better costed product, better through-life support, through-life costing of the product. And a number of times the procurement agency doesn't have a great handle on, it's not the $200,000, $300,000 to buy the vehicle. It's the X hundreds of thousands of dollars over the life of the vehicle. And what can we do to support the user to ensure that it has a better through-life cost and a through-life protection? I think that's the great challenge that's facing everybody.
Yeah, no, definitely, I agree.
Indeed. And part of, I've got to say, you and I have been in this business for about the same amount of time, 25 odd years. And so we've seen how the vehicles have changed, how the technology has changed, the standard, the testing standards have changed, training has changed. And so that's an important aspect as well. A number of the users, the fleet managers, the procurement people, they come and go every few years. And they don't have that corporate knowledge. They don't have that historical context as to what it is that they're doing. And that's another of the great challenges. And this is part of these conversations that we're having along the way. So another issue that we get from our clients in relation to glass, and I'll explain some of the challenges. Glass, when a user has to replace the glass, they would traditionally go back through their uparmourer, their supplier of the vehicle. And it makes sense. It's their design, their vehicle. They are the design authority for that vehicle. So the user goes back to the uparmourer and they buy a glass. So be it. And the uparmourer will go back to their original manufacturer, supplier of the glass, and they will get the glass in and they'll ship it to the user. As it happens, we're going through this with the British Embassy, one of the British embassies at the moment. And so it's all taking time. And this has been going on for probably 5 months already. We're still waiting for the glass to appear to enable us to assist them in installing the vehicle, the glass into the vehicle. So a number of times the client will come to us and say, look, is it possible for us to go to another manufacturer of glass that's not associated with the uparmourer, who can maybe reverse engineer the design to fit into this particular vehicle? And we say, look, that's a very good question. So let me ask you, as a glass manufacturer, is this something that is possible? Is this something that is done? How is it that this might assist the users of the vehicles?
No, absolutely. It's a good question, and it's something that we manage regularly. In fact, I just had a case of some glass arriving on our site yesterday. What ends up happening on a lot of occasions is that we are asked to support the replacement of some glass on a vehicle or a fleet of vehicles, but the customer who we are dealing with has no access to drawings or CAD data for us to be able to identify the actual design of the glass itself. If there's no CAD, if there's no drawings to be able to support that product, the only other way that we can support is by securing the actual glass itself, the samples of glass. So what we do at that particular point is we ask for the samples, and then we carry out a feasibility study on them, and then reverse engineer the glass to the exact original design. We can do that. It's something that we do regularly, again, because a lot of our clients do not have the ability or to have their own CAD and drawings supplied to us. So it's something that we're used to doing, and it means that the customer rather than having to buy a product that maybe might be similar but may not fit, which is then going to have an impact on the ballistic integrity of the vehicle. It may not have the glass supplied from the original supplier, but it will have exactly the same design to exactly the same ballistic threat level. One of the issues, for example, what happens if the original glass manufacturer has closed? And there's an instance that these things do happen, and on that basis, someone needs to be able to reverse engineer and duplicate that glass to ensure that the vehicles can still be operated.
Indeed. One of the challenges, and I know that we as a consulting firm had a client a number of years ago who had a very old vehicle from an uparmourer that is no longer in business, but the vehicle was in good enough condition that they were happy to continue to operate it. The glass needed replacing, and so we organised to very carefully pull the glass out of the vehicle. We sent it to a glass manufacturer. It wasn't you at this time. And they reverse engineered it and sent it through. What was important for the user to understand is, and in this case it wasn't a problem, is that the concept of the design authority chain, the chain of control, has now been broken. Now, when the uparmourer no longer exists, it's not a major issue. You can get around that. And they got around that through the drawings and the certification of the product rather than the vehicle. But where the uparmourer is around, obviously there's some, try to be diplomatic, there's some politics between the original uparmourer and the glass supplier if it's reverse engineered like yourself. And so that's a separate issue. Leave that aside. But there is a case where the user then no longer has that chain of control over the design authority. Now, in some cases, the user will accept that risk for a whole lot of reasons, and they will do their own risk analysis. They will understand the risk, and the appropriate authority within the organisation will accept and sign off that risk, and they will carry on. And so be it. And that's a very logical and acceptable way to operate. Some companies, organisations won't do it. I know I looked at it when I was with DFAT running the Australian government fleet, and my management team said we won't do it that way. We will only go back to the uparmourer and we will deal with it through that chain of control of the design authority. That's fine. We have other clients who don't do that. So it's good that you have that ability. I think it's a valuable service to the industry for a number of reasons. Again, if the vehicle is old, the uparmourer is no longer around, or as you said, the glass manufacturer is no longer around. And I had it, well, I was still with DFAT when GKN, who was a big supplier to the uparmourer that we were using, and they decided.
I have just the glass that I have arrived that I received yesterday, believe it or not, was a GKN glass product. They shut the manufacturing facility, and as it stands, the end user has no way of securing any drawings or CAD data from that original for those original products. So at that point, the end user either has to scrap their vehicle or find a solution. And the solution was that the glass needs to be replaced because of various delamination issues. They do not want to scrap the vehicle. How do we get around it? And we have found a solution. And within 8 weeks, we will have supplied that product. We'll have fully reversed engineered that glass, supplied it to our customer who'll fit it, and the end user has got a product which is exactly what they're looking for and meets that original ballistic threat level that when they actually purchase the original product.
Correct. And look, that's a reality of the industry. It changes. Armourers exist, and then, as we've had in recent times, that no longer exist, and their business is sold on to other organisations, or they close. We've had in Europe, UK, and America. It certainly happens. So there needs to be flexibility, and I think that's a great.
Wrong. It's far better to get CAD and drawings to be able to work from. It's far better to do that than you're working from the standard base tolerance of each individual glass. But unfortunately, that's not always possible, and we have a solution to be able to work around that and still supply an excellent quality product that meets the end customer requirement.
Indeed, and I. Again, we have experience. I've had experience from a not being permitted to an experience of being permitted to it. And again, I would suppose as a closing comment to this issue is that should this be the case, then the organisation that is procuring the glass should go through a risk assessment process to ensure that they understand what they're doing, what are the risks, how they mitigate the risk by going through a rigorous engineering process with the likes of your company, so that there is a connecting of the dots from a piece of glass, the design, the testing, the installation into the vehicle, so that that is taken into account, and so that whatever risks are there are mitigated as much as is possible, and the remaining risks are then accepted or not, as the case may be. And as with all risk, you can't avoid risk. Lying in bed all day doesn't avoid the risk of getting up and living. That doesn't happen. The aim is, as the risk assessment methodology says, is to mitigate, to investigate, understand likelihood, consequence, what is the resultant risk, can you re-mitigate that, and then therefore do you accept it or you don't. And that's how the process ought to work along the way. So thank you. That's very good. All right. So any final thoughts that you might want to share with us?
I would about the fleet managers and the vehicles being tied up to the original up-armouring company. So rather than the situation that we have here, just for your information, is that once a vehicle has been tested to VPAM, they can't change the glass supplier unless they do a full vehicle retest. So I would just like you to bring up that point because it's a real frustration for me at the moment, and a frustration for a lot of up-armourers that are in the industry as well.
That's a very good point you've raised. And going back some time, there was the possibility of doing a desktop analysis, whereby if the glass protective quality, the shape, the installation process was the same, then there would be some certification. And I know some of the European test agencies would then say, look, we might test the glass in the frame, we might test a door to say, yes, the glass in the door provides the same level of protection according to BRV as it did for the vehicle. There seems to be a hesitancy with that currently. And in fact, interestingly, in this year's CAV Forum, Tim Rennis, who's the chairman of VPAM, will be presenting about some of the updates to do with the VPAM standards. And that is certainly an issue that we've raised with him and the VPAM group in the past. Because if you change from GKN glass to Tyneside glass, then all of a sudden you've got to invest another $500,000 and retest the vehicle. It's ridiculous. There has to be a better way of doing it. And again, some conversations occur between a procurement agency and up-armourer to say, all right, you've changed glass, let's do a risk review, and we will then mitigate and we will accept risk, the resulting risk. And that's maybe acceptable.
From the information
should be that VPAM then has a process so that the VPAM test agency will endorse it. That's something that certainly needs more work on.
And that's one of the challenges that we have at the moment, is that that we have, and up several armouring companies who I know at the same point, if they have accredited the vehicle to VPAM certification, I do understand that the standards have been written to try and protect people and save lives. However, once the vehicle is being tested with the glass in, they cannot change the glass supplier unless they carry out a whole vehicle retest. It's very frustrating for a company like myself, who maybe wasn't on that original vehicle or didn't get the opportunity. And there's also frustration from several up-armourers that I've spoken to, that really they are locked into a supplier who they may now want to actually change, but unless they go through very expensive testing, they're not able to do that. There's a huge amount of issues that are incorporated in that. And what it seems to me like is that there is been a very much focus on, which there should be, to try and protect and save lives, but there hasn't been any commercial interest being taken in that decision and these standards. And that's something that I think needs to be considered moving forward for everyone's benefit.
100%. And I think this is part of the ongoing evolution of the industry, and particularly these last, I think probably 5 years or so. And I have to say, this has been our big push, and particularly through the likes of the CAV Forum, is to bring component suppliers, users, up-armourers, maintainers together to discuss these type of issues as an industry, because in the past, each of the individual stakeholders were rather stovepiped. The test agencies created a standard and they tested the vehicle. Finished. And that was the end of their job. The up-armourers built a vehicle, sent it into the field, end of their job. Through-life support historically has been very poor, and I will be diplomatically critical of the up-armourers themselves, as it is for the users who would take a vehicle, they would put it into the field and forget about it. The vehicle breaks down. There's $200,000 of vehicle sitting in a garage going nowhere because there's no one to repair it. There's no technical manuals. There's no spare parts. Can't get a windscreen, etc. So what is important is challenging the industry, including the test agencies, including the up-armourers, to think broader than just, I've got a tested vehicle and I sell it. Thank you very much, money in the bank. No, the industry deserves better. The end user, people like me who are sitting in a vehicle in Afghanistan or in Iraq, deserve better to know that the vehicle is as best as it could be and not suffering from non-commercial issues that are maybe difficult to face. So I endorse what you're saying, and I think that's the great push through the CAV Forum, through the likes of the type of work that we as a consulting firm do, through these conversations. And I think the hard conversations need to be had. Absolutely. Correct. And I'll raise one other point as we're starting to wrap up, is that the manufacturing process used to create the glass that was installed on vehicle 0, that was used for the test certification, may not be the same manufacturing process that's used on the glass that's going to be shipped to a vehicle that's 10 years old. Now, if that's the case, then the test certification for the glass is no longer valid. Now, a lot of people don't want to discuss that, and I can understand the complexities that can raise. But if you're saying that the manufacturer of the glass has to remain the same, then the manufacturing process of the glass that is used to certify the vehicle also has to remain constant. And it won't be. Over 10 years, I'm sure your manufacturing process has changed. It's enhanced. It's improved. It's a better quality. And therefore there is a disconnect within that. And that's something that the procurement agencies, the large organisations buying these vehicles, they do have a difficult time getting their head around. And I think it's incumbent upon the likes of ourselves as independent international consultants, yourselves as quality manufacturers of glass, to challenge the industry to say, we need to come up with a better way of doing this.
Right. I'm certainly trying to challenge it. Whether or not we'll have any, that will be generate any change, we'll have to wait and see. But it was an important point that I wanted to raise during this discussion, because it does need to be raised and people need to be aware of it. There's just a lot of frustration that it's a lot of people's hands are tied and they've got nowhere to go.
I understand. You being a young fellow, I think you might see the changes in your working life.
Not that young, unfortunately.
I'm well into the third quarter of the game, so make sure that the recruit that comes on in the first quarter is well trained to play a good game of Australian football or rugby, whatever the case. Chris, it's been fantastic having you. Thank you so much for sharing your time, sharing your knowledge, and sharing the challenges. As we've been discussing now, I think that's a very important part. So, thank you again for your time. We look forward to your involvement with the CAV Forum in October in Geneva, and certainly your expertise and your drive for making transparent armour worthy of the people who are going into harm's way, and I applaud you for that. Well done.
No, I very much appreciate the opportunity to come on. I thoroughly enjoyed and thought it was very beneficial, the CAV Forum last year in Geneva, hence the reason why I'm going again. There was some really good people there that we met, very knowledgeable in the industry, so I thought it was very beneficial. And we look forward to seeing you later on this year.
Excellent. Thanks, Chris. Appreciate your time.
Thank you.